Okay, what I'm going to explain to you is the expanding center algorithm for big O of n squared for finding a palindrome within a string. So there's some stuff here that you just have to take into account. I'm just going to assume you know what a palindrome is. It's the same, like BCCB is the same going backward and forward. And there's two types of palindromes. There's even and odd palindromes, and they're a little bit different. So if I say BAB, that has one center, and BAAB has two centers. So if it's odd, it has two centers, and if it's even, it has one center. That's why, if you look at this call, you call one with I, and then you call one with I and I plus one. The way this algorithm works is pretty cool. It starts off here, all right? And then it's going to go, okay, let's look at here and here. If either of these indices are out of bounds or the letters here and here are different, we're going to come back to it. We're going to return. So nope, we're not going to go through. And then you're going to call it like this. And then you're going to look here and here. But you won't even get there because the centers have to be the same. Right? So we'll run through how this works, but that's the basic idea. Is just you start in the middle and you build your way out. There's one thing I want to go over real quick for you. There's some couple minuses and pluses here. We're going to change this. In your code, you should write it like this. I minus lane over 2 plus 1. Okay. This just will make more sense. And this is kind of hard to remember. This way is easy to remember. So it's I plus length over 2 and I minus length over 2 plus 1. This takes into account our zero indexing of Java, right, or C++. So that'll like kick you over one. And this right here where you say R minus L minus 1, this is a fence post. This is a fence post issue. So let me just explain what that means. Let's say you have some fence posts. Oops, that was a very crooked fence post. That's a fence post. We'll just do it like that. Here's another one. Here's another one. Here's another one. All right, here's another one. I changed the settings of my tablet and it's super sketchy. So how many fence posts are between this one and this one? Well, let's say this is 0. And this is 0, 1, 2, 3, 4, 5. And this is 5. So we'll say 5 minus 0. There should be 5. No, there's 1, 2, 3, 4. So we have to subtract 1. The fence post error occurs when you take like the furthest number minus the beginning number to get the numbers in between. That's not how many numbers are in between. It's the furthest number minus the furthest minus the nearest minus 1. That's how many are in between. That's why you're subtracting 1 here, so you don't get a fence post error. So you don't, fence post error means you count by 1 too many. And you don't want to do that. That's really important to understand those two things. It makes the code just a lot more understanding and readable. So let's take a look at what's going on here. We're going to go ahead and say the length. Again, change it to this. I minus length over 2 plus 1. The reason why we're doing that is, I'll show you. Let's say we get to, we go to here. We'll run through the algorithm. We get to here. And then, I is 0. And then we call expand around center. And we're going to say left is 0, right is 0. Left is greater than or equal to 0. Yes. Right is less than the length. Yes. Fantastic. I kind of erased some of this, but s.chart I. Let's see if I could. Well, take my word for it. It says s.chart I. L.